From the paint shop, we have Rocker Reloaded. Rocker Reloaded, you may begin your presentation.
Alrighty, good evening. Welcome to our 2022 QCC for Sealer Redshift. I would like to start off by introducing the team. We have our theme leader, Marcos, aka Mouse. We have our gatekeeper, Leroy, aka Morpheus. We have our timekeeper, Gilbert, aka Tank. We have our data analyst, Sean, aka Agent Smith. We have our data collector, Isaac, aka Cypher. And we have our scribe and note taker, Justin, aka APOC. We have the circle leader, myself, Joey, or Neo. And we have our circle advisor, George, the architect. Our team safety commitment is to look out for one another by practicing Mendomi. So activity plan development, some pre-assessment. All team members are new to the QCC process. And we also have a first-time circle leader. Looking at the technical capabilities and circle dynamics, we are starting off at a low D zone. So the development plan, team members are to better understand TDP, learn the 8 steps of problem solving, take ownership of a step, and work together in a group. So a little bit of what we do in B-Process Sealer. Sealer is applied by both the robot and human to prevent water leaks and corrosion. In B-Process, we also apply Silent Guard, that is a sound dampener. Applications are then verified in dampening code confirmation. The vehicle is then sent to masking where stickers are applied. And from there, UBC robots apply the underbody coating. And last, the vehicle enters the UBC backup where some applications are brushed and confirmed. So referencing our FNBS board and using our theme selection matrix, we listed several issues impacting our process, and that being gaps on the rocker face, ranked the highest as impact to our customer, that being for possible corrosion. So, therefore, we are Rocker Reloaded, coming to you live from February. So a little bit of background with the launch of the new 780 model. Containment was initially set up to address the issue of damaged UBC stickers. During containment, gaps on the rocker face were also discovered, as shown here in this example, an example of the gaps being contained and repaired. Also, we received calls from Trim 1 East 20 for UBC and sealer interference with rocker trim installation for the same issue by the same rocker application and brush, as shown here in this example. Our ultimate goal is to provide solid structural integrity, not only as a measure of efficiency and skill, but also with compassion and care for our customers.
Sealer line, we're in. So we'll start off with step 1, clarifying the problem. Our current situation is 148 gaps on the rocker. Ideally, we want that to be 0, which leaves us with a gap of 148 to attend to. And this data was collected between December 18th, 2021, all the way to February 1st, 2022, out in the assembly chassis 1. I'll now pass it on to step 2 with Morpheus.
Step 2, breaking down the problem. We have 148 gaps on our rockers. Broke it up between left and right side. Left side came in with 85, right side came in with 63. We went with our bigger number, which was on the left side. Further broke that down into a greater location. We got 60 on our LC10 interior. How did this happen? It came from our 60 manual applications. With Genchi Genbutsu, our problem was first detected in assembly chassis 1. We walked it back, got it in UBC backup, walked it back again, pitch 7, walked it back again, pitch 4. And we further walked it back and finally got it in pitch 2 where we apply it. Prioritized point of incurrence, 60 gaps on our LC10 interior, the left side, front rocker manual application, and pitch 2. I'd like to give it off to Tank for step 3.
Step 3, set a target. Our goal is to eliminate gaps on the front LC10 interior at pitch 2 left rocker from 60 to 0 by March 31st.
Find the gaps and eliminate them. Wouldn't you say so, Agent Smith?
Step 4, analyzing the root cause. So after taking a look at our 4M+C, we found that our man, material, and environment were all adequate. As for our machine, we found that our robots cannot apply in that area due to limited access. As for our method, the standardized work, which required team members in UBC to brush gaps, was insufficient. Therefore, a tentative countermeasure was put in place to ensure good coverage of the LC10 and RC10 area, also found to be inadequate, leading us to our 5 whys. There are gaps in our rockers. Why? The method was inadequate. Why? Our countermeasures were inconsistent, which were our skive and brush in 4 and 7. Why? Our UBC standardized work for UBC brushing was insufficient, leads us to a root cause. Annual round tip rocker application did not provide enough material. We're passing it off to step 5, the cycle.
Step 5, develop countermeasures. During our journey, we tried multiple countermeasures, including pitch 2 bulb application, pitch 4 brush from interior, pitch 2 brush, and also pitch or 45-degree sky. All early countermeasures resulted in a non-conforming condition.
So some Genchi Genbutsu, after root cause analysis, our circle was struggling to find solutions. We had many disagreements.
Disagreements.
Whoa, whoa, whoa. I know what you're all thinking. Why, oh, why didn't I take the blue pill?
What are you talking about?
Matrix, haven't you seen it?
Oh, yes, I've seen it. So we asked Pilot for assistance. It was then recommended that we go and see the drawings of the 780 posted in the training room. And Pilot team helped us further understand the drawings. And according to legend, the area in question does not require coverage if there is good application on the seams. Whoa.
Countermeasures reloaded. For this, we used our countermeasure matrix and found that various tip sizes ranked the highest. Standardized work originally called for a 1.5 round tip or 1.5 round tip application. We decided to trial various tip sizes with the goal of achieving better coverage. And we found, after trials, we found that the 3mm V-tip ranked the highest. We then developed an action plan which consisted of Marcos creating WIS for the V-tip, Leroy and Gilbert would then consultate with Pilot. We would all then run trials. Myself would collect data from those trials, and Sean would analyze that data. We would then review our results. Initially, the V-tip seemed impossible. We started our impossible.
This is a moment where I need you to let loose and free your minds. In my left hand is a round tip. If you choose this, your story ends with nothing but gaps and defects. In my right hand is the V-tip. If you choose this, I'll take you to a world where happy customers exist.
Understanding the 780 model. The 780 model seams are doubled, hard to reach, and difficult to see, as seen in these examples. In UBC, the area is hard to reach, and the brush angle can impact assembly hole and bracket, causing interference, as seen in these examples from UBC. I will now pass it off for APOC for step 6.
So step 6, seeing countermeasures through. The current fundamental skills were based on the old 480 model and follow the seam during application, accommodating the 780 model. As stated before, the seams are doubled, and since only one seam can be applied at a time, we needed to find another way. So mimicking the robot application. To accommodate the 780, we devised a method that mimics the robot, and we Yoko-ten this to pitch 2 right.
Don't think you can, know you can.
So the following video is a demonstration of the new V-tip application, mimicking the robot in both half speed and full speed. So step 7, monitor both results and processes. We were able to achieve a 100% reduction of man's impacted gap, which left us with an in-process 71% reduction overall impacted gap. The robots account for the remaining 29% of gaps. This data is collected between March 20th and March 25th, 2022 in Assembly Chassis 1. Leading us into step 8, to standardize successful processes. We NEM washed with white shift, and we replaced the round tip with a 3mm V-tip in pitch 2 standardized work, as shown in the before and after here in ties. We eliminated the added motions, or Murray, which is the overburden of the team member. We improved ergonomics by removing elements from processes 4, 7, and UBC. We removed the bend and twist that was done in pitch 4 and pitch 7, as well as the reaching overhead that was performed in UBC. We were also able to improve cycle time, reducing 4 seconds for both pitch 4 and 7, as well as 5 seconds from UBC 1 and 3, for a total reduction of 13 seconds. This improved cycle time in UBC allows standardized work to be more efficient, giving team members more time to confirm all rocker applications, keeping in mind that time is the shadow of motion, and all motion takes time. So we changed the UBC standardized work from brush every rocker to confirm and brush only if necessary. Some testimonials we've gotten so far includes, "It's been doing well, much less of a burden," from Josh, a team member in UBC backup, as well as, "Besides the launch, we have had no interference issues," from Reggie, a group leader in Final East 120. All robot off-scene applications are now contained in process through improved UBC standardized work, resulting in zero flow out to customer. Now hand it over to Neo, the one.
So some additional benefits. You see the left-hand picture shows a round tip application, and it resulted in some SQA calls. On the far right, you see the V-tip showing a much cleaner application and looks better. Also, we're able to better provide coverage on the lower speaker scene's wider gap. On the far left here, you see the lower speaker scene gap without sealer. In the middle, you see the SQA call that we had in the middle. And on the far right is the V-tip application, clearly showing better coverage. And I would say that's pretty awesome.
Awesome.
All right, so reviewing future plans, team members feel more knowledgeable when using the 8 steps of the QCC process. Team members understand that through problem solving, we can truly understand the root cause of any problem. And team members now feel a sense of ownership and will continue to look for items to improve on in their process. For some future work, we plan to work with our specialists and SADI to fine-tune the robots. The robot applications to the rocker scenes to achieve a zero off scene. So looking at our technical capabilities and circular dynamics now, we began at a low D zone, and having gone through the struggles and accomplishments, we have leveled up to a low C zone. Now for some reflections.
This being my first body circle, I have a tremendous opportunity to grow and tackle these challenges with such a great team. Thank you for your time.
I learned how Toyota business practice plays a big role in quality control for their vehicles.
I learned the A step, problem solving, good away as a team. We're excited to move forward and see the results.
I learned how important it is to remain open and reliable.
I learned the importance of the 8 steps of problem solving and how I can use them in my day-to-day life. Thank you for your time.
I worked in a lot of different places in my life so far. And the first one that actually valued the input of the employees, where we were able to come together as a team, solve our problems, solutions actually be implemented.
For me, this is a good team building activity and a great way to grow. And that being, we have all new team members, and it's my first time in the circle.